Okay, so this is where we just left off with the last one, and I think it's probably good this is split into two videos because that way you can go back and watch one part versus the other. So we left off with this formula that was creating the width of our rectangle and the height of our rectangle. So using our same function, right, we have our negative x squared plus 5. If I think about calling the left variable a, so our starting point, and our right endpoint b, then the width of each partition is going to be b minus a divided by the number of rectangles that I want. So this creates the width of one rectangle. Well, then to get the height of each rectangle, let's just pretend that this was whatever our arbitrary width is. So this is b minus a over n. This purple rectangle has a left bound of 0 and a right bound of b minus a over n. So if I plug that into my function, I get the height of the rectangle. So I know I'm plugging something into my function. Well then, if I think about this next one, how many partitions did I go over? I went over 1, 2. So now this becomes my second iteration. So b minus a over n times 2. This one then would be b minus a over n times 3, times 4, 5, 6, 7. Apparently this one I'm deciding has 8 rectangles. So we want to increase b minus a over n by one interval each time. So I'm starting at 0 still, and I'm going to add to it the width of a partition times I. Now, in this case, I started at 0, but in our general case, we'll start at our left bound, which is a. Well, how many rectangles did I want? I wanted an infinite amount. So from I equals 1 until n, and I'll throw that limit in front of it. So using this for ours, the width of each of our partitions is going to be 2 minus 0 over n, which is 2 over n. So the sum of the areas is going to be the width of each rectangle times the height of each rectangle. Well, we're starting at 0 on the left, and we're going to add to it 1 rectangle, then 2 rectangles, then 3 rectangles, then 4 rectangles, and 5 rectangles, and 6 rectangles, etc., and get the heights by plugging into our function. All right, so using this and what we know from our work the last couple days, I can take this 2 over n out in front. So my limit's going to carry down. F of 0 plus 2 over ni. Well, my f of x was negative x squared plus 5. So that means f of 0 plus 2 over ni is going to be negative 2 over ni squared plus 5. So this is really, the 0 doesn't do anything to impact it, right? So I'm taking 2 over ni and plugging it in for x. This then is the stuff we've been working on. So this will become negative 4 over n squared I squared plus 5. We know from our summation formulas that 2 over n, this will become negative 4 over n squared, and then this becomes n times n plus 1 times 2n plus 1 all over 6 plus 5n. Keep going. Make sure you can still see my face. I'm still here. I'm going to distribute this stuff in. So I'm going to get negative 8n times n plus 1 times 2n plus 1 over 6n cubed plus 10n over n. And I'm still taking the limit as n goes to infinity. Well, the limit as n goes to infinity of this piece, this is going to be 8n squared, and this becomes 16n cubed. Well, 16n cubed divided by 6, n cubed, is going to be negative 16 sixths. and then I'm going to add to it. This limit is just going to be 10. So cleaning up my answers, this will be negative 8 thirds plus 30 thirds, which gives me 22 thirds. Now, 22 thirds in your calculator should be 7.3 repeating. And if you remember, we started with these estimates saying we were somewhere between 2 and 10. And then we were somewhere around 6.25 by the time we got to 4 rectangles. Well, if we had an infinite number of rectangles, our exact area would be 22 thirds. All right, I don't want to do that quite yet. One more time, our formula, which you are responsible for knowing. The limit as n goes to infinity, we are summing from I equals 1 to n. The width of each rectangle will be determined by our interval divided by the number of rectangles. And then we're going to take our partitions and we're going to plug them in to our function to get the height of each rectangle using this formula. So this represents the width, and this represents the height, and ultimately we want an infinite number of rectangles. I'll show a demonstration of this with YouTube when we come back on